5 years ago, the stack I'm about to show you would have required a full engineering team, a 6-figure starting budget, and 6 to 9 months of development. Today, I use it to ship enterprise-grade software in a matter of days, entirely on my own. In this video, I'm breaking down the 5-layer modular stack that mimics how professional product teams operate, adopting the same architecture behind companies like Notion, Linear, and Stripe, but compressed for the AI era. I've been a product owner in Fortune 500 companies, and I've run large development teams. But times have changed, and now I can build software all by myself. Just note, this isn't about memorizing tool names. Tools are important, yes, but they change every 6 months, or even less these days. This is about understanding the roles each layer plays, so you can swap tools in and out without breaking your entire system. By the end of this video, you'll understand exactly how to create software as a solo builder. It'll scale as your users do, and it won't trap you into vendor lock-in hell. And if you want to learn how to build with this stack yourself, check out Stack Labs in the description. Or if you're a founder who needs this implemented in your business, head to foundana.com. But before I show you the 5 layers, let me let you into a quick secret first. Most people in the AI space are looking for a no-code quick hack. This isn't that. This is actual software development. It's just faster, AI-assisted, and accessible to people who aren't engineers. Whether you're building a client project, or replacing an expensive SaaS, or turning an automation into a fully packaged product, you are essentially doing what professional product teams do. You're designing an interface, you're managing data, you're handling business logic, you're deploying updates. The difference is, instead of 10 engineers doing it in 9 months, it's you and a few days. But the critical part you need to know, and this is where most people screw up, you have to think in layers, not in tools. Because the moment you build everything inside one all-in-one platform, you're setting yourself up for disaster. Let me show you what I mean. A company I was consulting for about 6 months ago ran a B2B marketplace, connecting growth companies with marketers. When they first started, they built everything on Bubble. Made sense at the time. It was easy to use, no code, fast to prototype. They grew fast. Within 2 years, they doubled revenue and had grown a team to 8. And then they hit a ceiling. Performance started to slow, adding new features was a painful experience, and design decisions made a long time ago were starting to cause issues. Here's where it got really bad. They wanted to add a feature, messaging between users. Sounds simple, right? Bubble couldn't do it efficiently. The workarounds required would need a rebuild of half the app. Professional dev shops wouldn't really touch it and explained that the best solution was actually to start from scratch. They were trapped. The founder felt like he was being held hostage by the platform. And that's what happens when you build without modularity. Let's try to avoid this. Okay, but how? Well, you build with a modular system. 5 essential layers that work together, but they stay independent. Here's the breakdown. First, the front end, what users see and interact with. Second, back-end database, where your data lives. 3, the workflows and automations, the business logic that connects everything together. Then you've got deployment, 4th, and that's how you get everything to be published to the world. Finally, version control, which is managing and protecting your code base and asset. Each layer has a job. Each layer can be swapped. Each layer stays independent, and this is how you build software that scales without breaking, and it involves without trapping you. Now, I'm going to walk you through each of these layers, what it does, why it matters, and what tool I'm currently using for it. Then I'm going to show you how they all work together. But let me first start with why this matters. I know what you might be thinking. Sean, this sounds bloody complicated. Lovable just released their own database. N8N has a database feature too. Why not just use one tool for all of these components where we can? And I get it, it's tempting. One tool is easier to master. You have one login, one bill, simple, but that's a trap. There are 3 critical reasons you need modularity. First of all, tools should be used for their primary purpose. Dedicated platforms like Supabase are built specifically for database infrastructure. They're battle-tested for security, performance, and scalability. They handle millions of rows without breaking. A newer built-in database, for example, inside a front-end tool, it's really ready for production workloads. It's like using a Swiss Army knife instead of a chef's knife. It technically might work, but it's not optimized. Second, like before I mentioned, you want to avoid vendor lock-in. If you use a database that's embedded inside your workflow tool, you're tied to that platform forever potentially. If they raise prices, then you pay. If they shut down, then you're screwed. If they can't scale, you're stuck. By keeping each layer modular, you maintain total flexibility. If Supabase doubles their prices tomorrow, you can migrate to another Postgres in a weekend. If Lovable gets acquired and changes direction, at least we can rebuild the front end potentially in a different tool without touching the data. And thirdly, we're after scalability and control. All-in-one platforms often limit your control over workflows or infrastructure and architecture. By choosing the best tool for each layer, you can apply professional engineering practices like version control, automated testing, stage deployments, all of that good stuff that makes software and makes software last. This is the difference between a demo and a product. All right, let's get into each layer. But before we do that, if this content is hitting home for you, then please subscribe to my channel and drop me a comment on the type of content you'd like to see in future. Layer 1, the front end. This is what your users see and interact with. It's the interface, the buttons, the forms, the dashboards, the navigation. Most people think the front end is just about making it look pretty. That's wrong. The front end is where users experience the actual application in action. There's a number of options for this, but I use Lovable, and here's why. The front end is critical because it's what your team actually sees and uses. A good interface makes workflows intuitive, reduces errors and confusion, and increases adoption of internal tools. Even the most powerful back-end or automation won't help if the interface isn't usable. That's why choosing the right front-end platform matters. Lovable is my choice for a few reasons. Speed and flexibility mainly. You can iterate and update interfaces quickly as needs change. User-focused design means that it makes dashboards and forms intuitive, so adoption is easy, and it's integration ready, so it connects to your back-end databases and automation tools seamlessly. There's low barrier to entry. You don't need to be a developer to build professional, scalable interfaces, and these factors make it ideal for the internal tools I'm building today. Though it's not the only option out there. There are other front-end platforms that people use for internal tools, for example, and they have some strengths and some weaknesses too. Retool is very powerful for complex workflows and enterprise-scale tools. It's flexible and feature-rich, but can be more complex for smaller teams or quick iteration. Softer is good for simple user-friendly apps and dashboards, easy to get started, but may hit limits for more complex integrations. And there's Internal, which focuses on building internal apps quickly. But in general, I prefer the AI code builders these days, like Livable, and I'm using it because it hits the balance I need for speed, flexibility, and integration. But all these tools can work depending on your team's needs. The front end sits at the interface layer, so users interact with it, data flows to your back end, and then automations can handle logic. A good front end connects seamlessly to other layers, making the system usable and scalable. Lovable is designed to sit at this layer effectively, connecting your data and workflows to a clean, user-friendly interface. It has MCP connectors, for example, and some inbuilt integrations to database tools. The front end is a bit useless without any data, so let's talk about layer 2. I use Supabase as the backend and database for my internal tools, and here's why. The backend is the foundation of your software. A strong database layer ensures data is structured and consistent, security and access controls are in place, and workflows and automations can reliably pull and push information. Without a solid backend, your front end and workflows will either break or scale poorly. Choosing the right tool for this layer is essential. Supabase is my choice for the backend for several reasons. It's Postgres-based. You get the power and reliability of Postgres databases with minimal setup. It has real-time data tables, views, and subscriptions that update instantly, which is perfect for dashboards, and also has built-in auth and permissions, making managing access much more simple. It's secure and scalable. It's also API ready, can automatically generate APIs for your tables, which makes integration with your front end straightforward. It's very low-code friendly. You don't have to be a database engineer to start building structured apps, but at the same time, it's very powerful. This set of features makes Supabase ideal for quickly building and scaling internal tools without sacrificing control or performance. There are other back-end database platforms you could use depending on your needs. So Firebase, for example, is great for apps, and that's easy to get started, but less relational structure than Postgres and potentially harder to scale. Airtable, for example, is also very user-friendly. It's like a spreadsheet that's online. and it can integrate with a number of tools and integrates well with NA10, but it can be limiting. It's a bit complex when you start to scale. In general, I'm using Supabase because it hits the balance I need of power and simplicity. Remember, the back end is the backbone. It's where data flows and lives, and is an important component to add onto your front end. Automations read and write to and from the database in real time, and you have the security and auth components built in the back end. Supabase makes it easy to connect your database to your front end, like Lovable, and the automation layer if you want to add that in, like NA10, without complex setup, and it keeps it scalable and maintainable. So that's layer 2, your database. When your architecture is correct from the start, you'll save yourself months of painful refactoring down the line. Your front end and your database don't just magically talk to each other either. That's where layer 3 comes in. Often you need a little bit of magic when your systems talk to each other automatically and provide complex workflows and automations. This could be called the brain of your software often, and it's where a lot of the AI automations will live. I'm a big fan of NA10 for automations in my internal tools, and it's such a strong choice for connecting everything to your stack. You see, good workflows and automations turn a static tool into something that actually does things. A good automation layer lets you move data between systems without manual work, triggers actions automatically based on events, and ensures consistency while reducing errors. Helps you link tools together, and without a strong automation layer, your software will potentially still work, but your team might need to spend more time on repetitive tasks or connecting interfaces manually. NA10 is my tool of choice for automation tasks for a few key reasons. It's open source and flexible, so you can run it on your own environment and customize as needed. This keeps costs low. It has wide integration library connecting to almost any SaaS on the planet. Includes custom APIs and a visual workflow builder. Drag and drop interfaces make it easy to map out processes without coding everything manually. And a self-hosting option, as I mentioned, gives full control over the security and data, for example, if needed. So it's scalable for complex workflows, and it handles multi-step automations and branching logic, for example. All of these features help automate repetitive tasks, and then you can build front ends on top of it. There are other workflow and automation platforms out there, of course, each with their own strengths and weaknesses. Zapier is commonly known. It's very user-friendly, lots of integrations. It's simple to get started, but it's less flexible for complex stuff. And this is the same for Make, which used to be Integromat. Very powerful, visual and beginner friendly. Again, they don't scale so well, especially from a cost perspective, as you tend to pay per automation as opposed to NA10, which you can have on your own instance. So the automation layer sits between your front end and back end often, and it can move data about between the database and interface and triggers actions externally to your inbuilt system. NA10 makes this quite seamless, so your internal tools feel smart and responsive without adding manual steps. And that's layer 3, workflows and automations. When you build this layer with intention, your system becomes self-sustaining instead of constantly requiring manual intervention. So now you've got front end, back end, workflows all running. How do we get this thing live? So layer 4 is about deployment. This is how you ship your software to the world, how you get it from your local machine to a URL that anyone can access. And I'm a fan of Vercel for deploying internal tools. It's a strong choice for this layer for a number of reasons. Deployment and hosting are what make your app real and shareable, and a strong platform ensures fast, reliable access for all users, and it's easy to update without any downtime. This makes scaling a lot easier. Even the best designed front end and back end won't help if your app is slow, inaccessible, or difficult to update. Vercel is my deployment platform of choice for several reasons. Instant deployment, every change in your code or front end can update automatically. It's optimized for front end frameworks and works seamlessly with modern frameworks like Next.js, React, and more. Scalable infrastructure, meaning it automatically handles traffic spikes and scaling without extra setup. And you've got integrated previews that allows you to see changes as they're coming up. It's quite developer friendly as well, simple workflows that link into GitHub integrations and managing environments, for example. Yes, there are other deployment and hosting platforms that you could use. Netlify, for example, is also very good. It's great for static sites and front-end frameworks. It's easy to integrate CI/CD pipelines, and is probably just as good as Vercel. I'm just more familiar with it. There's Render as well, which is full-stack hosting, including back-end services. And you can use things like AWS and DigitalOcean as well for other enterprise-grade options. They are very powerful. They can be a bit harder just from a learning curve perspective. Just remember, deployment is the final piece that connects all of the layers, and the front-end interfaces become live for the users. Back-end is where the database sits, and of course, the workflow and automations can be housed in NA10. Vercel makes sure all of this gets presented to the user so that your updates are instantaneous and the app stays stable and responsive. Now we get to the layer that many solo builders completely ignore, but it's probably the most important one of them all. Layer 5, version control. This is how you manage and protect your code. It's your time machine, it's your safety net, it's your backup plan. Every professional development team uses version control. Every single one. It's a non-negotiable. But most no-code builders, they don't. They make changes directly in production, cross their fingers, and hope nothing breaks. And then when something does break, and it will, trust me, stuff always breaks, they have no way of going back. They're stuck, trying to remember what they changed and manually undo it. Here's why version control is probably the most important layer that you may well be ignoring, and how to use it, even if you're not a traditional developer. Don't worry, it's not that scary. This layer keeps your work safe, organized, and collaborative. I use GitHub for version control in my internal software stack, and it's critical that you do too. Version control is what makes software development manageable and safe. It ensures you can track every change to your code or project, collaborate with multiple team members without conflicts, roll back mistakes quickly if something breaks, and maintain a history of the project for reference or auditing. Even if you're using low-code tools or no-code tools, for your front end or workflows, having a robust version control system is essential. GitHub is my tool of choice for code management for several reasons. It's widely adopted. Almost every professional team I know uses it, so skills and integrations are transferable. There's branching and pull requests, which makes the collaboration and safe testing of changes quite straightforward, and it's very integration friendly, works seamlessly with a lot of deployment tools, and works with NA10 and Lovable, for example. It's free and scalable, and you can start small scale teams and even expand to enterprise level without switching tools. There's a great community and ecosystem as well, which makes it easier to debug and troubleshoot issues if you come across any. There are other alternatives to GitHub, like Bitbucket, for example, but honestly, stick with GitHub. It works. Version control, just remember, sits at the foundation of a maintainable stack and is what keeps all of your code in a single place. And that's layer 5. When you have this set up properly, you never have to fear about breaking something because you can always roll back. So, they're the 5 layers, all done. Just remember, the ecosystem is evolving fast. AI is rewriting the rules literally every month at the moment. New tools launch, old tools die, pricing changes, features get added or removed. The moment you become attached to a specific tool, you lose your leverage. But once you understand the roles each tool plays in the stack, you can swap them out anytime you want. You become future-proof. And this is how you build software that lasts. Not tools that break the moment you try to scale. Most builders are chasing the perfect tool, the one app that does everything. That tool doesn't really exist, and even if it did, potentially it would trap you for the reasons I highlighted earlier. What you need is a system, a modular architecture where each layer does its job and you maintain control over the whole thing. That's what professional product teams understand, and now with AI-assisted development, solo builders like you and I can use the same approach. The specific tools I use today, Lovable, Supabase, NA10, Vercel, GitHub, those might change. In 2 years, there might be better options. But the 5 layers, those will stay the same. You'll always need a front end. You'll always need a database. Yada, yada, yada. You get the idea. If you want to master this framework and learn to build using these tools yourself, if you want to move past the AI hype and actually build working software at scale, then come join us at the Stack Labs community. Links in the description. And then when you do start to actually build out software, you're going to want to avoid bugs. They are somewhat inevitable, but there's lots that you can do to try to minimize them in the first place. and reduce the consequences of them happening when they do. Check out this next video. It's got my top 10 tips for reducing bugs in all of your self-build projects.